I am discussing regression analysis here. We have been given a set of data, x and y coordinates, and we have been asked to determine whether it's a power function or an exponential function. So I'm using TI Inspire CX2 from home. I'm going to adding the list, and I'm preparing the list in column A and column B. I am naming them as variable x and y. In the next step, I'm going to the menu Stats, Stat Calculations. I'm choosing Power Regression. Either I can choose x as list A and y as list B, or variable x and variable y. And then in the first result column, I'm choosing column D, so that the analysis will appear in columns D and E. Yes, I'm getting these values now, and it says it is following the pattern 5 multiplied by x power minus 2, 1.9 and so on, and the r square value is 0.999959. It's pretty much close to 1, and it looks like a good fit. However, I would also like to check whether it matches exponential regression, and then I will decide whether it is a power function or an exponential function. Going forward now, again I'm going back to menu, Stat Calculation, Exponential Regression. I choose x list as A and y list as B. This time I want the result to be in column F, because D and D already we filled for power analysis and power function regression, and I'm using F and G for exponential regression. If I do that, I'm getting y equals 6.15 times 0.5046 power x, where r squared value is 0.9372. Now let us look at the r squared values. For the power regression, r squared value is 0.9999 and then 59. This one is 0.9371. Roughly we can say it is 99.9% good fit for power analysis, whereas 93.7% good fit for exponential regression. So we will go for power trend. Now the second question is, yes, we are getting the y value as especially the exponential function as not in power of e but in terms of b. Yeah. Is it possible to express it in terms of in the form y equals a e to the power b by bx? Yes, it is possible. What I do is I use nsolve from the algebra tool, and then I'm getting 0.693147. So I can write the expression as y equals 6.5 times e power minus 0.693x. Now, so far we have used only the list spreadsheet and then the regression analysis. Is it possible to do by graphing tool? Yes, it is possible. For me, it looks like slightly longer, but just we explore it. So in this case, what I do is first step is the same. I'm preparing the list, and the step 2 is different here. In step 2, what I do is that I go to menu, then to data, I am choosing quick graph, and then I am clicking on x-axis and I am selecting x, clicking on y-axis and selecting y, and graph appear like this. But here is a small window, but there are two sub windows. One is the spreadsheet, another one is the graph. Now what I do is that I move the cursor to the left, that's the border, and then I drag it to the left so that I will see the graph in a bigger window. Even we can do it in a smaller window, it's not a problem. So I'm just for convenience, I'm going for a bigger window. Now, yes, this is the graph plot. Now I will go to menu, analyze and regression. When I do that, I choose power regression. The moment I choose power regression, I am getting this graph as well as the best fit line as well as the power regression equation. Look at this. This is exactly same as what we got earlier in this one. Here everything appeared in the list, whereas here it is appearing next to the graph. That is the only difference. Next, but here the problem is it is telling us the equation, but I cannot find regression R squared value. How to do that? For that, what I do is that I go to document, insert, calculator, I go to menu, stats and stat results. Once I do that, I get stat result like this. Now our result are just a click away. The moment I click it, it displays all these values. Yes, it displays R square value as 0.999959, which is exactly same as we found earlier in the list. Yes, here we got 0.5599, same thing, we got it there. So this is another way of doing the same thing. So same step you can also repeat for exponential regression. Hope it is useful. Thank you.